Hi everyone, welcome back to our channel. Today we are going to discuss about the main concept in unit number 4, which is nothing but the charging of a lithium-ion battery. So you may ask a straightforward question: how to charge a lithium-ion battery? So here you see here, this is basically a structural setup how to charge our lithium-ion battery. Actually, this is not the kit we use it to charge the lithium-ion battery. Actually, this is the kit, the practical kit what we use. Then why you are showing this, you may ask a question. So in order to understand better, I am showing you with the help of an regulated power supply. So here we have two types of charging methods. First method is, which is nothing but a constant current charging methods, and next one is a constant voltage charging method. In constant current charging method, you can see here, so this is nothing but at x-axis you have the charging time, at y-axis you have the charging current of the battery, and one more y-axis you are going to have the battery voltage. So you have three coordinates. So now slowly, for this is nothing but the charging time for 10 minutes, 15 minutes, 20 minutes, and this is nothing but 1 hour. So in this 1 hour span, what's happening is, so in constant current charging method, so you are applying an constant current like this of constant magnitude. Slowly the battery voltages increases and it reaches one state. Okay, so up to here the battery may be charged to 90 percentage, starting with 0% of the battery, and this 90 to 100 is called as a fast. Here it will perform fast charging, and here it will perform trickle charging. Okay, so this method is called as a constant current charging method. So what to do or how to do here is, so you can see here how to perform constant current charging is, so here you have voltage knob as well as current knob. So this current knob we have to put in maximum position, then I can say that we are going to perform constant current charging method. So you connect these two terminals, so you can see here the batteries. As already we discussed the different types of batteries, the two types of batteries are, first one is lithium, already we studied this lithium ferrous phosphate batteries, and next one is nickel manganese cobalt batteries. So these are already outdated batteries, and these are the batteries what actually we are using. I think you know the physical structure of a battery. So this is nothing but the lithium ion nickel manganese cobalt battery. So this may directly catch the fire, and the latest batteries what we are using is lithium ferrous phosphate. If you want to know about the batteries, I will leave you a link in the card. From that you can see the construction of an lithium ion battery. So like this you have the battery cells which are done a spot welding, and due to some thermal failure, if a overcharge, it may undergo a thermal failure, and this thermal failure will lead to propagation in the case of an nickel manganese cobalt battery. To overcome this explosion, we are trying to use the latest batteries which are nothing but lithium ferrous phosphate batteries. So within the micro oven, if you heat these batteries also, that doesn't catch the fire. So this is one kind of batteries. So the famous batteries or the most popular batteries which doesn't catch fire is lithium ferrous phosphate batteries. These are also under the category of lithium. So if you want to see, you can see in the previous video I have been explaining you about all the different categories of batteries, which is nothing but lithium ferrous phosphate batteries, lithium cobalt, manganese cobalt batteries, you can see in the previous video. Now coming to here, the charging method, I already told we have to keep this knob in maximum position. We have to rotate this knob and keep in maximum position, and slowly we have to apply the voltage. For example, we have to apply around 60% of the voltage rating. So that's what we are doing here. So first initially you apply an constant current, and slowly gradually you have to increase the voltage level, then automatically battery reaches from 0% to 90 percentage of the battery capacity, and automatically this battery moves from 90% to 100 percentage, where we call this kind of charging as a trickle charging method. Okay, so basically this battery can be charged in two categories. One is charging the battery from 0% to 90 percentage is basically done with fast charging, but from 90 to 100 it is done as a trickle charging, but this trickle charging may damage the health of the battery. To overcome this issue, we have the this trickle charging will be done at a slow rate. Okay, we'll be doing at a slower rate. So that's why trickle charging may take more time to charge the battery. So this is what we discussed: constant current and gradually increasing the voltage from slowly we are gradually increasing the voltage, then automatically battery reaches 90 percentage and it reaches 100 percentage. So that's how we are indicating constant current we are applying and gradually we are increasing the voltage. The battery reaches to 90 percentage. From 90 to 100 it can reach it undergoes the trickle charging. This is all about how to charge an battery. So coming to the next way of charging the battery is nothing but reverse constant voltage charging. So here constant voltage charging, here the current we are going to decrease. Okay, so this is nothing but the charging time 10 minutes, 15 minutes, half an hour and 1 hour duration we are charging the battery. So here the pattern of current we are giving is initially we'll give an constant current and we'll try to reduce the current greater on. Okay, but the battery voltage will be gradually increased as already I told. So this is half of this part. Okay, so how I applied here, half of the part here also will give the constant current, but gradually will increase the voltage level and it reaches one threshold. Here 90% of the 100% of the battery is full, then automatically will make the current magnitude as 0 or will decrease the magnitude of current, but still the battery undergoes a trickle charging. So the percentage of battery here it may be around 95 percentage, and to come to this state it will be in 100 percentage. That's how the battery gets charged, where this is called the x-axis we have charging time and the battery voltage gradually increasing and we are giving constant current. So the same here we are going to do here. As per the diagram it's very clear that actually we have to apply constant voltage, but applying constant voltage is meaningless. This is nothing but slowly we have to increase the voltage. The slow increment we are going to call it as a constant voltage charging. So this is like an increasing curve, but approximately you have to take it as a constant curve. So current voltage is gradually, in a constant magnitude you are applying, but voltage is also supplied with a constant magnitude. This is how the battery gets charged, and you can see the complete figure. So for better clarity, so already I told, if you don't perform a proper charging, so this is the a typical understanding of an engineering student how actually a battery will be charged. But in practical, the Vola battery, what we use in Vola S14, the electric vehicle, we use this kind of fast charging. So they perform this kind of constant charging. I already told, so 0 to 90 percentage it has to perform fast charging. After 90 to 100% it has to perform slow charging. So this is called fast and slow charging. So we call this as fast charger. Okay, and this called as slow charging, and this type of charging is called trickle charging. Okay, so this work has to be done by this charger. Okay, so this is how the charger, what I mean to say is 0 to 80% of the battery, this is an 750 watts charger. So let us try to understand. So remaining 80 to 100 percentage it will work like only an 100 watts charger. Okay, so this is how we are taking into consideration. Okay, so this is how the Vola chargers work, which is nothing but they exhibit based upon the amount of charging in the battery. They perform slow charging as well as the fast charging. So if you don't do this charging with a proper charger, automatically some of the batteries may undergo imbalancing automatically, which may lead to increase of heat, and if one battery is getting heated up, it will try to create an explosion or the propagation which will damage. So those category of batteries are nickel, manganese, cobalt batteries. So easily they can catch the fire. That's why the government has banned these batteries, and the premium brands are not using these kind of batteries. The latest batteries which doesn't catch fire, which is nothing but LFB batteries, which are very powerful batteries, so they don't catch fire at any cost. So coming to this charging method, so we will see like stage wise. Okay, so you can see here the x-axis is nothing but the charging time taken by the battery. Let us take this one as a 15 minutes, this has some 30 minutes, and this has some 45 minutes, and this has like 1 hour. Let's try to classify it. At stage 1, you can see here the voltage per cell and current per the cell. So this is nothing but the current what you are supplying to the battery, and this is nothing but the voltage what you are supplying. So at first stage, the what happens is the voltage rises and the magnitude of current is constant. So this is nothing but voltage rises and the current supplied is constant by the charger. So in stage 1, constant current charging only will be performed. And coming to the stage 2, we have been charged the battery for 15 minutes. Now we are moving from stage 1 to stage 2. In this stage 2, what happens is we are applying constant voltage, but gradually we are decreasing the voltage. So this comes under constant voltage charging method, and this comes under constant current charging method. Then you can understand better to what I want to say here. So here this is nothing but constant voltage charging, but current gradually decreases. You can see here constant voltage you are supplying, but current is gradually decreasing. So at stage 2, you can understand the voltage is of maximum value, but the magnitude of current is going to decrease. There's nothing but the current decreases. And we have been reached to an third stage, which is nothing but at third stage all 90% of the battery is full. Here it is, the battery percentage is 0, and it has reached approximately some 70 percentage, and to here it has reached 90 percentage. Now at stage T, the battery is almost all full, the charger terminates. But 90 to 100 percentage, what happens is it perform slow charging, or this charging we are going to call it as trickle charging. And this trickle charging is performed with low magnitude of current, but with the required amount of voltage. So this trickle, this is called trickle. I mean, like this trickle, I mean, will suddenly will charge it with lesser current and higher voltage, and ultimately occasional topping of the battery. So successfully within 1 hour, we made our battery as full with the help of these advanced chargers. So this charger has constant voltage charging and constant current charging, as well as it can perform trickle charging. So this, you may ask, sir, this is not an actually way to explain, but if you want to understand theory, the practically is nothing to show physically here. There are a lot to show here physically, and these are the two terminals of the battery where we are going to connect. So this is one terminal of the battery, this is another terminal of the battery. So from this also you have two wires which will be directly connected to here. One is positive and one is negative. So this is how practically you need to understand how we perform constant voltage charging as well as constant current charging at the different stages of charging. So my suggestion is, if you understand the lithium-ion battery charging methods, then you are very clear about the types of charging. So nowadays the best available batteries are lithium ferrous phosphate batteries, which doesn't catch fire at any cost, and never it undergoes a thermal runaway. So due to charging or due to manufacturing issues also, our nickel manganese cobalt batteries, due to rise in temperature or due to overcharging or due to excessive heat in the battery due to continuous use, it may, one cell may undergo a failure. This cell will become like a cumulative, which will raise the temperature, which is called thermal runaway, and automatically the complete battery may explode. This is called the risk of lithium-ion batteries, which is called thermal runaway will happen. So to solve this problem, the latest batteries, you can see here, this battery is directly kept in the micro oven, it doesn't blast. Then you can understand how it is able to understand the heat balancing or thermal runaway problem. So hope the content is very clear. If you feel the content is very useful, please like the video and please share with your friends, and please give me your valuable comments wherever you have the doubt. And if you are watching our channel for the first time, please subscribe the channel and please support us. Why? Because this is a free channel only to educate the students. So please give us a valuable support by giving a valuable subscription and continuously watch the video. We'll meet in one more video about nickel metal hydride batteries, and next battery we'll discuss about hydrogen fuel cell batteries. Thank you for watching. We'll meet in the next video. So this is all about today's. So please watch the videos which will help us to do more videos which will like a support. Thank you. Yours obediently Ram.